All right, boys and girls, I thought I'd do a video today on factoring, and these are special cases. So similar to what we did yesterday. So if you look, we have 4m squared minus 25. And so it's still quadratic, and the reason why it's still quadratic because it's got a square, okay? Has an exponent of 2. So let me put it this way. So ax squared plus bx plus c. Now, if I'm going to compare it to this, you're going to notice that a is 4, okay, because that's our term with the square. And then 25 is our c, that's our constant, okay? But what you notice, there's no middle term. We're missing the bx, okay? So ready? If I'm going to identify my a, my b, and my c coefficient, we're going to have 4, 0, and negative 25. Okay, so if I follow the same procedures as yesterday, I'm looking for two numbers that multiply to give me whatever a times c is. In this case, a times c is going to be negative 100. Let me do it in a different color. And then we're looking for those same numbers here, to add and give us whatever b is. And in this case, our b is 0. So when do you multiply two numbers and end with a negative? Is when one's negative, okay, and one's positive. So same thing here. And think about this. When do you add two numbers, a negative and a positive, end up with a 0? That's when these two numbers are opposites of each other. So those are kind of hints to help you come up with those two numbers. They have to be opposites of each other. So basically, whatever they are, they'll be the same number, except one would be negative, one would be positive, because then they'll cancel each other out and get a 0. So can you think of those numbers? If you chose negative 10 and positive 10, that's perfect. That'll work. Negative 10 times 10 gives you negative 100. Negative 10 plus 10 gives you 0. Okay? So now we follow yesterday's procedure. These are our numbers. Remember, we want to look at the first term. We have 4m squared. So when I write it out, I should be writing out as 4m times 4m. Excuse me. And then in here, we're just going to write negative 10 plus 10. Okay, so we need to write this twice because we're going to multiply. But remember, when you multiply them, that's going to give you 16m squared, and we want 4m squared. So we either have to get rid of the 4 or reduce. So remember, the goal is to not end up with fractions. So if I divide by 4 here, I'm going to get a fraction. If I divide by 4 here, I'm going to get a fraction. So instead, think of this. What do 4 and 10 have in common? What's the greatest common factor? If you chose 2, you're correct. So you're going to divide by 2. And then that'll give you 2m minus 5. And then over here, what's going to happen is if we keep the 4m, if we multiply the first terms, we're going to end up with 8m squared. So you're also going to have to divide by 2. Okay. So now we end up with 2m plus 5. Okay. And this is our final answer, 2m minus 5 and 2m plus 5. Notice a couple things, okay? Because after a while, there is a pattern and you can solve it a little bit faster, okay? Notice our factors are pretty much the same, except one's minus and one's add, okay? Addition. So the reason why is this is the difference of perfect squares, okay? The difference of perfect squares. What happens is if you were to FOIL this right here, your middle terms will cancel out. And the reason why they cancel out is because one's negative and one's positive. Okay. So let me show you another one. Okay. So I'm going to show you this one, which is much easier. Okay. And then I'm going to show you a little bit of a trick that makes things go a little bit faster. Okay. So I showed you the other one, kind of traditional, but again, this is the difference of perfect squares. So ready? N is a perfect square and 25 is a perfect square. So this is kind of a little hint, okay? Because again, it's pattern. So if I want to find the square root of n squared, that'll give me n. If I want to find the square root of 25, that'll give me 5. So I'm going to repeat these factors, n and 5, except one is going to be positive and one is going to be negative. Now, if you don't believe me, you can multiply through and you should be able to get what you started with. So let me show you. Again, I'm doing FOIL. N times n is going to give me n squared. N times negative 5 is going to give me negative 5n. 5 times n is going to give me positive 5n. And 5 times negative 5 is going to give me negative 25. So notice my middle terms, one's negative and one's positive, and they're the same, they're opposites. So they're going to cancel out. So we're just going to be left with n squared minus 25. Okay. So that's kind of the shortcut. And that happens when you have perfect squares, okay? So it's the difference of perfect squares, okay? Again, difference of perfect squares. So let me give you a formula, which I don't memorize, by the way. I just kind of already know it. So whatever your first term is, if it's a perfect square, minus whatever your second term is, if it's a perfect square, when you factor, you should pretty much get a minus b times a plus b, okay? So you can memorize this, put it in an index card, but this is kind of the formula, okay? And this is called the difference of squares, okay? Now this only happens when it's a minus, okay? So difference is subtraction, okay? So write that down. All right, let's do another one together. Okay, here we have another one. It's a to the fourth minus 9. Now, what changed in this one? Now I did a higher power, okay? A to the fourth. But is a to the fourth a perfect square? And the answer is yes. I can break down a to the fourth as a squared times a squared. So those are perfect squares, okay? So now if I wanted to do my shortcut, remember, we want the square root of a to the fourth, which is just a squared. So I would get a squared. And the square root of 9, which is 3. So my two factors will be a squared and 3, but I want one of them to be plus and one of them to be minus. By the way, the order doesn't matter. I could do the minus here or the plus here, okay? That doesn't matter, okay? And it'll save you some time, and it'll save you like work, okay? And you can do it a lot faster this way, okay? All right, awesome. Let's do another one. Okay, so the next one I'm going to give you is 2n squared minus 98. So again, you're going to ask yourself, is this a perfect square? And the answer is no this time. 2 is not a perfect squared, although n squared is a perfect square. Is 98 a perfect squared? No, it's not. And you can check by using your calculator. So this one's a little bit different. So if you notice, they're not perfect squares, but if you recall, what I taught you yesterday was always look for the GCF. So do me a favor. They're not the difference of perfect squares, but check to see if there's a GCF between these two. Because 98 is even, then 2 will definitely be a common factor. So we're going to factor out a 2, okay? So when we factor out a 2, then we're left with n squared minus 98 divided by 2 gives you 49. Okay, after you factor out your GCF, now ask yourself, is this a perfect square? The answer is yes. Is this a perfect square? The answer is yes. So if that's the case, then now you can go ahead and factor what's inside the parentheses. Okay, now you can factor that out. So with that being said, the square root of n is going to be n. The square root of 49 is going to be 7. So my two factors should be n minus 7 and n plus 7. Okay, and don't forget to bring down the 2 because you have to keep it. It's part of it. Because again, if I were to multiply all of this through, I should get exactly what I started with. So that's a way to check your own answers, okay? All right, awesome. Okay, so now I'm going to give you a couple for you to try on your own. All right, boys and girls, now I'm going to give you 3 problems for you to try. The first one is x squared minus 36. The second one is 3x squared minus 48. And the third one is 4x to the fourth minus 64. Okay, copy those down, pause the video, try it on your own, and then come back and check your answers, okay? All right, pause the video. All right, boys and girls, let's check your answers. If you did it correctly, you should have gone in for letter A, x plus 6 and x minus 6. And again, you can switch them. Doesn't matter what order. For the second one, these are not perfect squares, but if you factor out a 3, then you're left with x minus 4 and x plus 4. And then for the last one, these are actually both perfect squares, but you can factor out a 4 ahead of time, which makes it really nice because then it's the number is much smaller. And then you'll end up with x squared minus 4 and x plus 4. So similar to the previous one, okay? If you got them all correct, then keep the video going. If you got them wrong or any of them, pause it and go back in the chat and ask me questions, okay? Okay, this next example is actually similar to what we learned yesterday. Actually, it's it's the same thing as you did yesterday. I just wanted to show you this one. 4x squared minus 4x plus 1. This is a quadratic, but it's also a trinomial. So I want to remind you ax squared plus bx plus c. Okay. Nothing too fancy about this one or completely special. I just wanted to show you this one. So again, you would do it just like yesterday. Factor, identify your a, your b, and your c. So a is 4, b is -4, and c is 1. And you're still going to look for two numbers that multiply together to give you a times c, and two numbers that add together and give you b. Okay. So if you multiply a times c, you'll get 4. If you if you write down your b, that's just -4. Okay. So you're looking for two numbers that when you multiply give you 4, but when you add give you -4. So when do you multiply two numbers, get a positive, but add them and get a negative? And that's when two numbers are negative. Okay, so think about that. Okay, so can you think of those combinations? Okay, you should have gone 2 and 2. Okay, -2 times -2 is +4. -2 plus -2 is -4. Okay, so those are our numbers. And then when you go up, remember, you're looking at your first term, and we have 4x squared. So we want to write it as 4x plus 4x. Okay. And then what do we do with these numbers? We just bring them down. So just like yesterday, okay? Here's kind of, I guess, the twist. Remember, if I multiply 4x and 4x, I'm going to get 16x squared. So we want to simplify this. If you look at each of them, they're exactly the same. So whatever I do here, I'm going to do here. So in this case, I'm going to divide not by 4, but by 2. Okay? Now, I hope you agree with me, but whatever I get here, I'll get exactly the same here. So this will now give me 2x minus 1. And since I'm going to get the same thing here, then what I'm going to do, instead of repeating it, just put a square. Okay. So again, everything's exactly like yesterday. So remember, this is the same as saying 2x minus 1 and 2x minus 1. But since your factors are exactly the same, the shortcut to write is just put a square. Okay. All right, awesome. Okay, moving on to the next part. Now I'm going to be showing you factoring by grouping. Okay, so if you're completely fine with this, then let's keep it going. Okay, so now I'm going to show you factoring by grouping. Okay, remember, grouping means you probably use grouping symbols, and grouping symbols in this case are going to be parentheses. Okay, so the example that I'm going to show you is 12p to the third minus 21p squared plus 28p minus 49. Now, this is not a quadratic because our leading term has a cube, okay? This is not the difference of perfect squares. This is not a trinomial, none of that. So this is something new. Instead, if you notice, we have 1, 2, 3, 4 terms. So if you ever wonder, when do we use factoring by grouping? It's when it has 4 terms, okay? It has to have 4 terms. So when you think of this word, think of parentheses, grouping symbols. So what you're going to do is actually do that. You're going to group them. You're going to group them in groups of 2. Notice the plus, I left it in between. So this is one group, this is another group. So then after that, what you're going to do is you're going to look for the GCF within each group. GCF. So concentrate just on this group of parentheses here. And then look for the GCF. So between 12 and 21, what's a common factor? 3. Between p cubed and p squared, what's a common factor? P squared. So now what you're left with is 12 divided by 3, 4. P cubed divided by p squared, p. Then you're minus 21 divided by 3, 7. And p squared divided by p squared is 1, so you don't have anything left. Now, you know you've chosen the greatest common factor if between these two terms, there's nothing else you can factor out. Okay, so you're done. Now we're going to put plus. Now we're going to do the exact same thing in between these two terms. So look for the greatest common factor between 28 and 49. Okay, you should have chosen 7. And so what's left? Notice there's a p here, no p here. So the only thing I could have factored out is a 7, no variable. So what's left is 28 divided by 7 is 4p minus 49 divided by 7 is 7. Now, you should notice a pattern. Now, you know you did it correctly because here's another hint. What's left in parentheses should be exactly the same. Exactly. Okay? If they're not, then you did something wrong. So you might want to go back and check, okay? So what's left for you to do is just to take the common factors here and just combine them. So what you're going to do is you're going to write 3p squared plus 7 and then times 4p minus 7. Okay? And that's your final answer. Now, if you're wondering, wait a minute, this will give you this? Yes, absolutely. Okay, it'll give you that. Okay, you can FOIL this and you should be able to end up with what you have at the beginning. Okay. All right, so this is just one example. Let me give you another one. Okay, here we go. Here's another example. 6v cubed minus 16v squared plus 21v minus 56. Again, because there's 1, 2, 3, 4 terms, I know automatically I'm going to do factoring by grouping. Okay, so group them. Okay, and again, look for that GCF here. Okay, so between the coefficients 6 and 16, I can factor out, I believe, just a 2. And then between the variables, the highest one is v squared that they have in common. Okay, so what I'm left with is 3v minus 8. Okay, and again, there's nothing factorable here, so I'm done. Plus, I just bring down that plus. Between 21 and 56, I can factor out, I know factors the 21 are 7 and 3, and 7 goes into 56, so 7. And this one has a variable and this one doesn't. So this would be 3v minus 8. And again, you know you did it correctly because what's in parentheses is showing up exactly the same, okay? So just take your coefficients and put them into one parentheses. So 2v squared plus 7. And then these repeat, but you only write it down once. 3v minus 8, okay? And that's your final answer, okay? And again, you should be able to FOIL this and get the same answer, okay? All right, let's do one more together, and then I'm going to give you guys one to practice on your own. Okay, so I have 105n cubed plus 175n squared minus 75 minus 125. And I don't know if you heard me, but every time I said it, I kept ending with the 5. And so right away with something kind of, I see a pattern or I hear a pattern, I can tell, you know what, all of these are divisible at least by 5, okay? If you don't know if there's a bigger number, then you can always just factor out a 5 and then you can check at the end. But what I notice is they don't all have ends. Oops, this one's missing an n. Sorry. They don't all have ends, but I know they all have a common factor of at least 5. I don't know if it's the greatest, but I know they have a common factor of 5. So what I'm going to do is factor out a 5. And I'm going to do it now. I'll know if this is the greatest at the end. And this is kind of a hint to check, okay? So 105 divided by 5 should give me 21n cubed. And the nice thing about factoring it out too is that my numbers get smaller. Plus 175 divided by 5 is 35. So 35n squared. Minus 75 divided by 5 is 15. Minus 125 divided by 5 gives me 25. Oh, don't forget my n. Okay. Okay, and this is what I should have so far. Okay, so now we're going to do grouping. There's 1, 2, 3, 4. We're going to group them in here. So what I'm going to do is I'm going to add some parentheses. So I'm going to add a parentheses here. And then notice this time we have a minus instead of a plus. So what I'm going to do is I'm going to add a plus. Hold on, let me show you. I'm going to add a plus, and then I'm going to add my parentheses here. But remember, the 15 was normally negative. So let me put a negative there. And this is still negative, but because I put a plus here, we're going to keep it as negative, okay? This is the only one that changes. So me distributing the plus won't change anything, but this one should be negative, okay? Okay, now, again, that's the only change I made. So now I'm going to factor out in here. So ready? Common factor between 21 and 35. And I know 7 and 3 go into that, and 7 and 5 go into that. So I'm going to factor out a 7. Ignore this 5 for now, okay? Just concentrate on the parentheses. So factoring is 7. And then between the ends, I'm going to factor out n squared, okay? And then I'm left with 3n plus 5, okay? Then I'm going to bring down the plus. And then see how there's a negative here and a negative? I'm going to end up factoring out a negative, okay? Let me put it in parentheses. So I'm going to factor out a 5. And then now I'm left with positive 3n. And then because I factor out a negative, because they both have negative, I should have a positive 5. Remember, if I multiply negative 5 times 3n, I'll get negative 15n. If I multiply negative 5 times 5, I'll get negative 25, okay? So again, remember, we ignore this 5 for now, but we'll bring it down in a minute. So now that my parentheses are exactly the same, combine these into one parentheses. So now I should have 7n squared minus 5, because that's negative, and then 3n plus 5. And now what I'm going to do is now, since I factored out the 5 at the very beginning, I'm going to bring it out here. So now I'm going to attach the 5, okay? And then my answer should be 5 times 7n squared minus 5 times 3n plus 5, okay? All right, so let me give you a couple for you to try on your own now. Okay, the first problem that I would like for you to try is 28v cubed plus 16v squared minus 21v minus 12. And the second one is 21k cubed minus 84k squared plus 15k minus 60, sorry. Copy them down, pause the video, and then come back for the solutions, okay? Okay, for the first one, if you did it correctly, you should have gotten 4v squared minus 3 times 7v plus 4, okay? For the second one, if you did it correctly, you would have noticed they would have all had a common factor of 3, and then you would have factored out and you would have gotten 7k squared plus 5 times k minus 4. If you didn't notice that at the very beginning they have a common factor of 3, when you get to the bottom, let's just suppose you might have had, say you didn't factor out the 3, and you were left with 21k squared plus 15, then you would have said, wait a minute, I could still factor out a 3. And then if you would have factored out the 3 at the end, that would have been okay. Okay, and then this is what you get. Okay. If if you didn't get any of these correct, or one correct and one wrong, come back in the chat and I can help you. Okay. If you did, then let's keep it moving. We're going to move on to the next part. Okay, for this next example, we have 4xy plus 6 minus x minus 24y. Okay. Excuse me. Looking at all four, there's no GCF, so I can go straight to grouping. Okay. If you didn't like my method earlier about changing the signs, you can just add a plus and just put this in parentheses. Okay, since they're both negatives, that might be easier. Okay. And then I want to focus in the first parentheses and factor out a common factor. So between 4 and 6, I can factor out a 2. Notice they don't have any variables in common, so I'm going to keep the xy. And then, oops, I should have kept a 2xy plus 3. Okay. Then I look at these two, and I know they both have a negative, so I'm going to factor out a negative and just a -1 because there's no coefficient here. And then here we have an x, and here we have a 24y. Now, here's what's going on here. You're going to notice they're exactly the same. Exactly the same. So then what's going on? You'll notice that there's nothing we can't rewrite this in a different way. So it's not that it's not factorable. What happens is when they gave us the 4 numbers, we had to write them in a different order. Okay? So guess what? This is wrong. So let me erase it again. Let me give you the original. The original was 4xy plus 6 minus x minus 24y. What we have to do is we have to regroup them. Okay? So 4xy, 6, negative x, and negative 24y, we have to switch them. So earlier we had 4xy, and then earlier we had negative x. So we cannot put 6 here, and we cannot put 24y. So why don't we switch those? Okay, we'll put negative 24y here, and then we'll put plus 6 here. Okay. I don't know. Let's see if this works. Okay. So it's kind of like trial and error. So I'm going to group these two now, add up my plus, and group these. So if I look in these first 2 parentheses, again, I'm going to write it down. I just regroup them. Okay. We group them. So I'm going to look in these 2, and what I can factor out is a 4 and a y. Look, I can factor out a 4 and a y. So now if I factor out a 4, I'm left with x. Oops. I said a 4 and a y, and I just wrote down 4y. So I'm left with x. That's it. And in this one, I'm left with negative 6. And since I factor out a y, that's it. So look, 4xy divided by 4y, I should just be left with an x. Over here, I should just be left with 6. And that's it. Now over here, what you notice, there's nothing in common. But I can't copy this down exactly the same, because then they're going to look different. Your x has to be positive and your 6 has to be negative. So to make that happen, to make them look the same, I'm actually going to factor out a negative 1. Then a negative 1 times an x will give me a positive x, will give me a negative x. And a negative 1 minus a 6, so the negative and a negative will give me a positive. So now they're looking the same. So now that they're looking the same, I can write them as 4y minus 1 times x minus 6. Okay? So now they're factorable, and I can do that. So sometimes you might have to regroup them. Okay? So that was an example of one. So let me give you one for you to try. Okay, so the last one that I'm going to give you to try is 9mz minus 4nc plus 3mc minus 12nz. Okay? Pause the video, try it on your own, and then come back for the solution. Okay, so for this one, you should have gotten 3m minus 4n times 3z plus c. Okay? Again, if you got this one correct, then you have enough, boys and girls, to move on and start today's homework. If you got it wrong or you were confused in any part of today's, then come back in the chat and I can help you. Or you can go ahead and start the homework, and as you have questions, just ask me, okay? All right, remember, today is mostly on special cases, finding those shortcuts and grouping, okay? All right, boys and girls, good luck.